Okay, so this is our second video on linear equations in two variables. As I said at the end of the last video, one of the main things this is going to focus on is finding equations of finding equations for linear equations, meaning actually knowing what the variables for like m and b are. And so let's go ahead and look at, we have another useful form here. This is called the point slope form. And this is useful for finding equations. And so the point slope form is the following. We have y minus y1 is equal to m times x minus x1. Now, in this point slope form, we still have that x and y are my variables, so they'll be still present in your final answers. And then we also have here x1, y1 is my point, kind of where the name comes from, point slope. x1 and y1 is a point, and this is just any point on the line. And then m, of course, is just my slope. And then when finding equations, we put our final answer in slope-intercept form. So we use the point slope form to find the equation, and then we rewrite it in the slope-intercept form. So let's look at a couple examples here. So the first one is going to be a pretty straightforward example. Let's look at this here. So find the equation of the line that has slope of 2 and passes through the point 3, -7. And so we've got to use the point slope form here, but let's just look off. It's pretty straightforward, this example, because we're given the slope, so m is equal to 2, and then we're also given a point on the line, 3, -7, so this is just x1 and y1. And then of course our point slope form is y minus y1 is equal to m times x minus x1. And then we just substitute the numbers in and put it in slope-intercept form. So we'll substitute in, we'd have y minus -7 is equal to 2 times x minus 3. Then we just simplify this and put it in slope-intercept form. So we'd have y plus 7 is equal to 2x minus 6. Then to finally put it in slope-intercept form, we subtract 7 from both sides, and we get 2x minus 13. So pretty straightforward on this example. Next example we're going to look at isn't that much more difficult, but it just requires one more additional computation here. So we're going to find the equation of the line passing through 2, 4 and 4, -4. Now the difference here is they haven't told us what the slope is. We have 2 points on the line, but we don't know what the slope is. But that's not a big deal, because when given 2 points, we know we can compute the slope. We saw that at the end of the last video. So let's go ahead and just label these points again. x1, y1, x2, y2. And let's go ahead and compute my slope then. So the slope here would be -4 minus 4 over 4 minus 2, which would be -8 over 2, which is simply just 4. Now I have my slope, and I just use my point slope form. So my point slope form again is y minus y1 is equal to m times x minus x1. And so we'd have y minus, well, y1 is 4 is equal to, I forgot my little negative here, it's -4 there. Slope is -4 times x minus 2. Now we go ahead and still put this in slope-intercept form. So this would be y is equal, I'm sorry, not y is equal, I want to take this in 2 steps. Y minus 4 is equal to -4x plus 8, and then I'd add 4 to both sides and we get -4x plus 12. Now, I want to emphasize here, it doesn't matter which the point we use as x1 and y1 or x2 and y2. We already know that with slope, but let's just verify it's the same thing with the point slope form as well. So let's do this as x2, y2, and this one as x1, y1. Now, I'm not going to recompute the slope. We did that on an example on the previous video, and we know that the slope is still going to be -4, because we already know that it doesn't matter which point you use in what order. As long as you keep the points consistent, you'll get the same slope. Alright, so we already know the slope's going to be -4. But let's look at what would happen with the point slope form here. So we have y minus y1 is equal to m times x minus x1. But then what we'd have here now is we'd actually have y minus -4 is equal to -4 times x minus 4. So lots of 4's all over the place. And the one thing I want to point out right now here, this is why we don't typically leave them in point slope form, is that it looks like if we compared these two equations right here in point slope form, they don't look the same at all. You know, they look like they have different numbers. It doesn't look like the same equation at all. But we'll find as soon as we put this in slope-intercept form, we'll see that we get exactly the same equation. So let's continue putting this in slope-intercept form. We get y plus 4 is equal to -4x plus 16. Subtracting 4 from both sides, we get y is equal to -4x plus 12. And again, we can see now that they're both in slope-intercept form. Yeah, we get the exact same equation. Alright, now the last thing we're going to talk about on linear equations before we move on to a new topic is parallel and perpendicular lines. Now some of you might be familiar with this, which is good, but some of you may have not seen this before. Now there are sometimes symbols that people use for parallel. Sometimes people use two kind of slanted lines there for parallel. Sometimes they'll even make them vertical. And then perpendicular, you'll often see this symbol here for perpendicular. Now let's talk about parallel lines here. Well, one thing that's unique about parallel lines is parallel lines do not intersect, and therefore have the same slope. You can prove that, we're not going to, but you can prove that if you have two lines that never intersect, that they have to have the same slope. Just as the same way you could prove that if you have two slopes that are exactly the same, that you would never have those lines intersecting. We're not going to prove those formally, but you could do that. Alright, so parallel lines. Let's look at a quick graphical example here. So let me put a graph down here, slide it over, and let's look at the equations y equals 2x plus 1 and y equals 2x minus 2. Now these are pretty straightforward to graph. They're in slope-intercept form, so I just plot the y-intercept and use my slope. So for the first equation, my y-intercept is, of course, 1, and then I have a slope of 2. So I'd go up 2 over 1, up 2, and over 1. And I'll go ahead and go down 2, 1, 2, and over 1. And then, of course, we draw a straight line as best we could through those points. Alright, so then let's plot the other one. So it's got a y-intercept of negative 2, and then we go still a slope of 2, so up 2 and over 1, up 2 over 1, and then we would draw a line through these points here. My lines drawn aren't perfect, but you can kind of see, just even from these here, that these are parallel lines. They'll never intersect, and they clearly have the same slope because the equations tell me they have the same slope, just looking at the two equations. Alright, so that's parallel lines. Then let's look at perpendicular lines. Perpendicular lines, one thing is that they do intersect, but they intersect and form a 90-degree angle at the intersection. That's what's special about perpendicular lines. It's not just that they intersect, because any two lines that don't have the same slope will intersect. It's just that this one, they have 90-degree intersection. Well, we are going to look at what's the relationship of their slopes. The relationship of the slopes is that they're negative reciprocals. Slopes. And what do we mean by that? Well, if we want to know what the slope of the second line is given the first line, it's just negative 1 over m1. So you do a negative reciprocal to get those slopes. Now, another way to view this, and it's the way I sometimes view it, is that you can also think it is if you multiply the two slopes together, you get negative 1. Okay, so let's look at a quick example, a graph of perpendicular lines. Alright, so let's look at y equals 2x plus 1, and then y equals negative 1/2 x plus 2. And we can see that these are definitely going to be perpendicular lines, because if you do 2 times negative 1/2, you get that this is negative 1. Or you can look at the fact that they are negative reciprocals. If you take 2 and do the negative reciprocal, you would get negative 1/2. Alright, so let's go ahead and plot these. So y equals 2x plus 1, so 1 is the y-intercept, up 2 over 1, up 2 over 1, And then let's go ahead and sketch our line here. So that's the 2x plus 1. And now we're going to do negative 1/2 x plus 2. So we have y-intercept of 2, and then we would go, for instance, up 1 and back 2, or down 1 and over 2. And then again, do your best job to draw a straight line through those points. And now, it's not a bad sketch here. It's not perfect, but we can kind of see that, yes, at this intersection, as I said, it's not perfect, but yeah, that is definitely going to be forming a right angle there, 90 degrees. All right, so let's look at an example here with parallel and perpendicular lines, and that will kind of wrap us up on linear equations in two variables. So, given the equation of a line is 4x minus 2y equals 3, find the equations of the lines that are parallel and perpendicular that go through the points to 1. Okay, so we want to find parallel and perpendicular lines to that equation, and that also go through the point 2, 1 here. So this is really going to be using point slope again, but before I do that, I know that I'm going to need to know what the slope of this original equation is, because if I know the slope of what this equation 4x minus 2y equals 3 is, I know parallel lines have the same slope, and I know that perpendicular lines have negative reciprocals. Okay, so let's go ahead and look here. So to figure out what the slope is, of course, we would just put it in slope-intercept form. So you got negative 2y is equal to negative 4x plus 3. Of course, divide everything by negative 2. And that would give me y is equal to, well, negative 4 divided by 2 is positive 2. So 2x, and then I'd have minus 3/2. The minus 3/2 really isn't what's important here. What's important is that I've got a slope of 2. Okay, now let's look at the parallel lines. So the parallel, well, we know that a parallel line is going to have the same slope, so my slope is 2. And then I also know the problem tells me it goes through the point 2, 1. So now I just use my point slope form. Y minus y1 is equal to m times x minus x1. And then I would simply write down, plugging in everything, y minus 1 is equal to 2 times x minus 2. Put it in slope-intercept form. So y minus 1 is 2x minus 4. And y is equal to 2x minus 3. So that would be a parallel line to the original equation. And yes, it does, we can see it has the same slope, but of course the y-intercepts are different. Now let's look at finding the perpendicular one. So perpendicular, well, we know perpendicular lines have negative reciprocals. So if my slope for the original line is 2, the negative reciprocal of 2 is negative 1/2. And then, of course, I'm still going through the point 2, 1. So again, we use the point slope form. Y minus y1 is equal to m times x minus x1. So we'd have y minus 1 is equal to negative 1/2 times x minus 2. So you have y minus 1 is equal to negative 1/2 x being careful of my negatives, I'd get plus 1 then. Adding 1 to both sides, we wind up with y equals negative 1/2 x plus 2. And so those are our two equations here. This one's the perpendicular one we just found, and then this one, of course, is the parallel one. All right, so this wraps up our discussion on linear equations in two variables. We're now going to move on to, in the next video, talking about functions. And functions are a very important concept in mathematics.